Okay, so this is number 6 from the notes. We have this identity that we're going to work with. I know this is on the double angle notes, but we're actually not going to work with the left side. I don't really want to have to deal with that tangent of 2x situation. We're going to get a tangent squared on the bottom. That's kind of nasty. So let's try to work with the other side. I'm going to go ahead and change everything to sines and cosines because that generally is helpful. So if we work with the right side here, 2 is going to be 2 over 1. I know I'm going to be changing things into, I'm going to have lots of fractions. Cotangent is cosine over sine. Again, I'm going to have a 2 over 1. Cosine cubed is in the numerator. And I have cosecant as 1 over sine. And if you look here, you really only have 2 terms. It's a little hard to see because of the way I've written it here, but here's your first term, here's your second term, and they have a common denominator, which is awfully nice. So I'm going to write this all over my common denominator of sine of x, and it is 2 cosine of x minus 2 cosine cubed. And I know we talked through this when we were working with our more basic identities, but when you see a degree bigger than 2, you probably don't want to be thinking Pythagorean identities at that point. You want to be thinking factor. So if I look at the numerator there, I have 2 cosine x minus 2 cosine cubed. They have 2 cosine in common. And if I do take out the 2 cosine, remember I have 2 terms left in my parentheses. 2 cosine times 1. And then I have cosine squared, not 2, sorry about that. And then I have 1 minus, and then I have cosine squared left. All over sine of x. So I know my goal is cosine of 2x. Cosine of 2x, remember, is cosine squared minus sine squared. So let's go ahead and change. We know we need some sines for 2 reasons. We need sines for tangent of 2x and for cosine of 2x. So I'm going to go ahead and change that 1 minus cosine squared into sine squared. And you don't really need those parentheses, but I'm just going to keep them there to show that's what we multiplied. And I know you are absolutely dying to cancel here. So let's go ahead and do that. We can cancel a sign on top and a sign on bottom. I'm going to go ahead and add a page here. So what I have is 2 times cosine times sine. That's what's left. Well, 2 times cosine times sine is the same as 2 sine cosine. And you will remember that that is the same as sine of 2 theta, or sine of 2x. Well, that's awesome, and that's super simple. But that's not what we were trying to prove. So let's look at the other side of our proof here and see what we were trying to prove. We needed tangent of 2x times cosine of 2x. So we still have a little work to do. Let's think about what we have and about where we're trying to go. We have sine of 2x. We're trying to get tangent of 2x, cosine of 2x. So I'm not working on the other side. I'm just going to do a little bit of scrap work here. Imagine if this was on a piece of paper, this would be over on the margin. I just don't have margins here. So tangent of 2x is 2 tangent of x divided by 1 minus tangent squared, or you can write it as sine of 2x over cosine of 2x. That always works for tangent. So there is a sine of 2x that matches on both sides. So that's pretty sweet and pretty good news for where we are. The other thing we have on this side, or the other thing that we need that we don't have yet, is this other cosine of 2x in the numerator. So what we need is a cosine of 2x in the denominator to give us tangent of 2x, and a cosine of 2x in the numerator. And we can always multiply by 1. So let's try that. So we're going to multiply by a super creative fancy form of 1, and this is sine of 2x over 1, by cosine of 2x over cosine of 2x. So what we have, if you want to reorder, think about this a little differently, is, because remember, this is all multiplication. You can think about multiplication and division all in the same step. So we have sine of 2x over 1. We have 1 over cosine of 2x. And we have cosine of 2x over 1. Just breaking those three, really two fractions, just breaking them into 3 terms. That's one term, that's one term in the denominator, and then we have another term in the numerator. And then we can, because with multiplication order doesn't matter, we can group these however we want. So I'm going to group these two together and make them sine of 2x over cosine of 2x. That's where creativity and being able to see things just a little bit differently really helps with proofs. Sine over cosine is tangent. And we have that cosine of 2x. And there's your proof. Really, if you could get to the spot where we had sine of 2x, if you could get there all by yourself, you are killing it. You're doing a really good job. These other little things are the reason that we're going to be practicing for a whole nother week before we have the test. Alright, so if you got through this problem, go ahead and work on the online practice for sum and difference and double angle. Tomorrow in class we will work on the couple problems that I didn't make videos for and work on half angle.